Okay, so welcome to this video again. We are going to solve a question based on dynamics. Specifically, we're trying to look at what we call the Atwood's machines. But mostly, this question is based on a pulley. So it goes like this. They're saying two masses M1 is equal to 5 kgs and M2 is equal to 10 kgs are tied to the opposite ends of a massless rope, and the rope hangs over a massless and frictionless pulley as shown in the figure below. So I'll draw a figure before, before, but let me try to read the questions through. So the question goes like this again. They're saying find the acceleration of the two masses. What is the tension in the rope? Then they're saying how far must two drop in the first 2 seconds. So we have two different things here. We have this is a pulley, then we have two objects, this one and that one. So this is my M1, then this one is said to be M2. So we know that M2 is equal to 10 kgs, this one is 5 kgs. So the understanding here has to be like you have to look at what exactly is going to make the entire system move. So in this case, since this one is bigger as compared to that one, definitely this is going to move downwards. It will point downward. It will make the entire system move downwards. Then this one is going to be moving in the upward direction. Now, if you check, what are you supposed to do? Since this type of emotion doesn't involve things like friction and the like, what you have to understand, these two things are going to be moving. They won't be at a stable point, like maybe they won't be at a fixed point just like that. No, they're going to be moving. And how are they going to be moving? This one is going to be moving downwards. The only thing which is going to make this move downward is the weight of it. Then this one is going to be pulled up by the tension, meaning that here you can first of all draw what we call the free body diagrams. How do you draw the free body diagrams? You have to focus on what direction each object is going to move. This one is going to be accelerating upwards, this one is going to be moving downwards, meaning that the acceleration for this one is going to be calculated as follows. Still, it is going to have a weight force that is going to be pointing downwards, but it will be less than that one, meaning that the upward force that is going to make this move, you have to subtract it by what? The downward force. Here you say the downward force minus the tension which makes it move slowly. So I'll draw the free body diagrams based on these two different objects. I'll have this. So this one is going to be moving downwards, mg. This is m2. Then this one, its mass is trying to put down, but it is less than the tension which is being experienced there. So you say mg1, then the tension has to point upwards. This one also, tension is trying to point upward, but it is less than the force which is moving downward. What are you supposed to do? You are going to have two different equations in this case now. Okay, and the first equation is going to be based on this diagram, which is m1, then this is m2. How are you going to draw, or how are you going to focus on the forces for this one? Both they are going to have these forces because they are moving in y-axis. You say the summation of forces in the y-axis must be equal to ma. Why do I equate it to ma? Is because these two they are going to be accelerating, but the acceleration for this one is going to be named as m1 multiplied by acceleration. These two they are going to have the same acceleration. Why? Because they are attached or they are tied to the same tension. So what you're going to understand here, you have to say, since this one is moving upwards and this one is moving downwards, meaning that this minus that has to give us the acceleration for this, tension minus this has to give us the acceleration for that one. So I'll say T minus m1 G has to be equal to m1 A. You come to this one, you say m2 G minus T has to give us m2. Why do we do it like this? It's because here the tension is the one which makes this one move upward, and then here is the weight force which makes it move downward. So the force which is making the system move downward has to be on the positive side. The one which is trying to oppose has to be on the negative side. Okay, we move on. So here you have two different equations. This becomes my first equation. This becomes my second equation. You can add this and that. How do you add? We learned about simultaneous equation, how to add the equations. So we're going to have T minus m1g equal to m1a. Then we're going to have m2g minus T equal to m2 a. Then I will add. If I add this and that, automatically this and this one will be cancelled. We're going to have this and that only. So we're going to have m2g minus m1g, giving us m1 plus m2. I'll multiply everything by acceleration. You divide m1 plus m2 over m1 plus m2. You cancel. Acceleration is going to be equal to, so in this case we can also factor out g. So g in m2 minus m1 over m1 plus m2, meaning that acceleration has to be equal to what is mass 2. So g in this case we have to take it as 9.8. So say 9.8 open 10 minus 5 over 10 plus 5. So acceleration has to be equal to 9.8 multiplied by 5 over 15, meaning that our acceleration in this case is going to be equal to, so you come here and you say 5 multiplied by 9.8, we are giving it gives 49. You divide this by 15 and we are going to get 3.27. so meaning that the acceleration for this one has to be 3.27 meters per second square. This becomes the acceleration for the entire system. Now, what are you supposed to do for you to come up with the tension? You can just pick whichever equation you want. You can either have this equation or you can get this one. Still, you're going to get the same answers. So let me try to use this equation. I'll make this the subject to a formula, meaning that this has to move to my right-hand side. So we're going to have T has to be equal to M1A plus M1G. Okay, so in this case, I'll just make M1 the subject, meaning that T is going to be equal to, say, M1 open A plus G. Remember, G has to be the gravitational acceleration. So we're going to have T equal to 3.27 plus 9.8, meaning that tension has to be equal to, so we're going to have, okay, 3.27 plus 9.8, getting that, multiply everything by 5, we're getting the tension as 65.35 newtons. As simple as that. That is the second question, which is B. If you go to C, they're saying C. In C, they're trying to tell us that what is the acceleration in the first 2 seconds. Okay, so initially these two objects, if you check in this diagram, you're going to understand that this and that initially they were at rest, meaning that if you use that formula for displacement, you say H has to be equal to V initial T plus 1 over 2 A T square. So they're saying what will be the height. I don't know if they're saying height or whatever. Yeah, how far. So since they were initially at rest, this is going to give us 0 due to the fact that the initial velocity is going to be equal to 0. Meaning that the height, or rather the distance they're going to move, has to be like this. You say multiply by 3.27 multiplied by 2 square. H will be equal to, the calculator is there, just come here and say 3.27 multiplied by 2 square. You're getting that, you divide this by 2. Sorry. So I'll say 3.27 multiplied by 2 square. We're getting that, you divide this by 2. We're getting 6.54 meters. As simple as that. Thank you for watching.